In the name of God, hello dear students, welcome back to Fairclass website. My name is Masood, I'm a physics teacher. We are here in Fairclass website at your service to explain physics curriculum grade 11. In previous lesson, I explained the constant acceleration or uniform acceleration. Uniform acceleration means changing velocity by the same amount during equal time intervals. Changing velocity by the same amount, let's say during equal time intervals, like free fall objects. For example, this marker, if whenever you release it from a certain height, this marker becomes a free fall body. And free fall bodies in general possess constant acceleration, right? Why do we say free fall bodies possess constant acceleration? Because in each second, the velocity of the free fall body increases by the same amount. In each second, the velocity of the free fall object toward the center of Earth, their velocity increases by approximately 10 meters per second. That's why the acceleration of these objects is constant and is equal to negative 10 meters per second squared approximately, right? This is called constant acceleration. So in physics, actually there are four main rules. We obey these rules for determining the velocity, for determining the displacement, for determining the time interval or acceleration of objects that move with constant acceleration. And if I say free fall body, this subject is not just for free fall body, because uh, there are a lot of motions uh, that that they don't belong to free fall. Free fall. They don't. They are not considered free fall. For example, a car moves with constant acceleration, and car moves horizontally, while free fall moves vertically. So, constant acceleration does not mean, say, free fall acceleration only. It consists of horizontal motion and etc. Right? There are four rules. We obey these rules for finding the initial velocity, final velocity, as I told you, acceleration, and etc. In each, let's say, in each rule, we have a proof. We prove the rule, and after that, we solve a sample problem. We solve some practices, and after that, we will move on to the second rule. So after that, whenever we reach the second rule, second formula, we prove the second formula mathematically. We solve a sample problem, practice, and after that, actually we obey this sequence. Right? Let's move on to the first one, and the title of our subject is laws of motion with constant acceleration, or I told you, you can say uniform acceleration instead of constant acceleration, right? The first rule, displacement depends on initial velocity, final velocity, and time. So what's our duty, right? What's our duty? Our duty is to what? Our duty is to find the rule that includes displacement. It starts with displacement, and this rule, uh, actually I told you, it starts with displacement, and this displacement uh, depends on initial velocity, final velocity, and time interval. So our formula of displacement should include these factors: initial velocity, final velocity, and time interval. Let's move on the proof. Actually, this is proof. You have to start from here. We have a diagram. We have a graph. Let me read the explanation for the graph. The figure below is a velocity time graph. There's a velocity time graph of a ball moving in a straight line. A ball, or for any free-fall object that moves vertically with let's say in a straight line with constant acceleration. This graph is dedicated for these objects, right? So we uh, let's say determine three different positions: initial velocity, v average, and final velocity, right? Average velocity for a moving object is found by these two equations. So E average, or V average, excuse me, V average is found by two equations. These equations, let's say, are old equations. We have information about these rules. V average is equal to delta x over delta t. So either V average is equal to delta x over delta t, or V average is equal to VI plus VF divided by 2. VI plus VF divided by 2, it uh, it gets you the average, right? It gives you the average. Equating the equations 1 and 2, equation number 1, equation number 2, whenever you equalize them to one another, you get the delta x over delta t is equal to VI plus VF divided by 2, right? And I've told you over and over again in physics, whenever the left side of, I don't say left side, whenever one side of two equations, two physical equations, whenever one side of two physical equations uh, actually is uh, is the same, right? One side of two equations is the same, like this equation, V average, V average. So the other side is equivalent as well, right? That's why uh, I can equalize delta x over delta t to Vi plus Vf over 2, like this. Because the left side of these equations is the same, which is equal to V average, right? So we keep going the proof. After that, cross multiply the equation, the new equation. We want to cross multiply the equation like scissors, like this. Delta x multiplied by 2 becomes 2 delta x. Vi plus Vf within the bracket multiplied by delta t. That's the second one. So after equating the equations, we cross multiply the fraction. After that, you have to divide the both sides of the equation for, let's say, canceling 2 from the left side. Let's see the result. Dividing the both sides of the equation, right, of the former equations, it gives us this equation. Delta x is equal to 1 over 2, or 1 half Vi plus Vf within the bracket multiplied by delta. This is the first rule. Are we done? Did we get the, did we reach our goal? Yes, because the rule, or the first rule, says that displacement should depend on initial velocity, final velocity, and time interval. And we reached this goal. Let me show you the former explanation for the former title. Displacement, you see, displacement depends on initial velocity, final velocity, and time. And right now we have the mathematical formula, mathematical form for this text. delta x displacement depends on initial velocity, final velocity, and time interval. That's why delta x is equal to 1 half vi plus vf inside bracket multiplied by delta t. This is the first rule, right? I'm gonna finish the lesson here. Thank you very much, guys, for watching this video, and bye for now.